Why did this multi-billion-dollar vertical engineering marvel suddenly turn into a global death trap? Hidden structural imbalances on this karst cliffside defy the traditional laws of architectural physics. A single minor mathematical discrepancy in weight distribution triggers a catastrophic kinetic chain reaction. Massive concrete support platforms instantly splinter under the crushing weight of thousands of tons. Terrified operators watch high-strength carbon steel anchors snap like threads under extreme tension. Dozens of multi-ton luxury vehicles plunge into the deep abyss as structural bridges collapse. High-risk construction crews battle intense level 11 wind gusts at a staggering height of 300 meters. Industrial rescue helicopters struggle to stabilize against furious mountain air currents during the evacuation. Emergency response teams descend along thin steel cables over roaring, highly dangerous cliffside waterfalls. This massive structural failure proves that extreme futuristic architecture carries highly volatile operational risks. To excavate the jagged karst cliffside, industrial workers utilize autonomous laser demolition drills. The structural foundation requires high-strength carbon steel anchor bars driven 50 meters into bedrock. Massive automated casting yards forge thick metallic plates to withstand incredible vertical pressure forces. Heavy structural columns are lifted into position by colossal specialized mountain tower cranes. Industrial operators securely tighten thousands of specialized high-tensile locking bolts along the framework. The central elevator shaft integrates powerful heavy-duty servo motors for continuous high-speed movement. Automated transport tracks smoothly deliver smart vehicular trays to designated multi-layered berths. Advanced three-dimensional laser coordinate sensors map every square millimeter of the high-tech tower. Massive computer control centers monitor the extreme stress levels of the structural joints. Heavy hydraulic tensioning jacks continuously pull thick internal cables to stabilize the building. Violent mountain wind gusts create severe twisting forces along the entire perpendicular framework. Microscopic fractures propagate rapidly through the concrete when load limits exceed the safety threshold. Industrial rescue helicopters battle brutal air currents to evacuate personnel from upper platforms. Emergency response crews rappel along thin metal guidelines past roaring cliffside waterfalls. This architectural crisis proves that extreme futuristic engineering demands absolute mechanical precision control. Advanced seismic dampening systems are integrated into the tower base to counter severe geological vibrations. Massive automated conveyor tracks continuously deliver raw carbon steel trusses directly into the mounting zone. High-precision computer systems calculate real-time weight distributions across all active vehicular docking layers. Industrial welding networks melt high-strength alloy joints using specialized plasma cutting and bonding beams. Colossal magnetic stabilizer rings are rapidly positioned around the main elevator column structure. Heavy-duty electric transport pods smoothly transfer modern vehicles into highly secure vertical storage quadrants. Optical sensor arrays emit thin blue scanning grids to verify the exact platform balancing parameters. Autonomous maintenance drones continuously inspect the outer structural skin for microscopic metal fatigue cracks. A sudden drop in hydraulic system pressure triggers emergency warning strobes across the complex. Violent crosswinds slam against the massive metallic structure, creating extreme mechanical twisting stresses. Heavy load-bearing support cables suddenly snap under tension, creating violent kinetic shockwaves through columns. Dozens of multi-ton autonomous vehicles break loose and slide dangerously toward the cliffside edge. Industrial-grade emergency choppers brave treacherous mountain air pockets during a high-stakes evacuation effort. Highly trained industrial response personnel deploy massive steel safety nets across the crumbling framework. This terrifying mechanical failure highlights the volatile limits of building extreme futuristic high-altitude architecture. Heavy industrial concrete mixers continuously pump high-performance liquid composite material straight into the lower foundations. Automated hydraulic gripping arms rapidly clamp large structural steel load beams onto reinforced cliffside columns. High-frequency electromagnetic induction heaters instantly temper critical metallic connection plates for maximum structural density. Colossal automated dual-hook gantry cranes hoist complex multi-tiered vehicular platform modules into active building sectors. Industrial operators utilize synchronized hydraulic torque wrenches to secure heavy structural framework joints together. The primary vertical transport spine integrates multiple high-voltage superconducting magnetic levitation tracks for rapid transit. Advanced smart shuttle platforms smoothly distribute multicolored modern vehicles into computerized honeycomb storage compartments. High-intensity optical coordinate scanners continuously emit thin orange laser sheets to check real-time mechanical tolerances. A centralized artificial intelligence mainframe monitors millions of structural sensor points across the tower. Massive high-pressure pneumatic bracing systems continuously adjust internal counterweights to minimize structural lean angles. Severe level 11 atmospheric wind currents violently rock the outer geometric metal cladding of the structure. High-stress structural connection bolts violently shear off under immense mechanical twisting and pulling forces. Industrial emergency response helicopters face extreme mountain downdrafts while performing critical platform extraction maneuvers. Highly specialized safety crews deploy heavy mechanized anchoring cables to stabilize the shaking framework. This immense infrastructure crisis demonstrates the dangerous physical boundaries of high-altitude automated architectural design. Automated magnetic scanning grids systematically analyze the internal molecular alignment of newly anchored steel trusses. Heavy multi-stage hydraulic drills create precise vertical chambers inside the limestone cliff for core foundation pillars. Continuous robotic casting conveyor units inject high-density titanium-infused alloy straight into critical structural junctions. Colossal motorized multi-cable hoisting rigs transport entire prefabricated modular parking decks up the cliff face. Synchronized pneumatic locking wrenches secure heavy-duty carbon alloy support nodes onto the tower spine. The primary vertical elevator shaft integrates twin-coil linear induction tracks for smooth electromagnetic car transportation. Smart dynamic shuttle sleds automatically guide multicolored luxury vehicles into computerized matrix parking slots. Advanced laser coordinate tracking cameras continuously broadcast real-time dimensional data back to the mainframe. An autonomous artificial intelligence network continually scans the mechanical load balance across all support platforms. High-pressure nitrogen gas shock absorbers rapidly modulate internal structural dampers against intense mountain vibrations. Brutal level 11 atmospheric storm winds create immense aerodynamic resistance along the geometric metallic skin. Massive high-tensile structural support bolts violently fracture under extreme kinetic shearing forces without warning. Heavy twin-engine rescue helicopters battle severe vertical wind shear while attempting high-altitude platform extractions. Specialized industrial safety emergency units deploy thick, mechanized steel cabling networks to restrain shifting structures. This massive multi-level infrastructure failure demonstrates the highly unstable limits of extreme futuristic structural engineering. Industrial concrete induction pumps blast ultra-dense synthetic polymer slurry into deep geological anchor channels. Automated hydraulic gripping lattices clamp huge carbon steel support rings onto reinforced vertical pillars. High-frequency electronic induction lines instantly temper massive structural connection blocks for extreme density. Colossal automated dual-hook tower cranes hoist multi-tiered vehicular platform structures high above the abyss. Industrial operators utilize synchronized pneumatic torque systems to lock critical structural framework units together. The primary vertical elevator shaft integrates powerful heavy-duty servo motors for continuous high-speed transit. Smart magnetic shuttle sleds smoothly shift modern multicolored luxury vehicles into computerized storage quadrants. Advanced optoelectronic laser coordinate tracking systems emit thin blue scanning grids across the tower. A centralized artificial intelligence network continuously scans millions of structural load balance points simultaneously. High-pressure nitrogen gas cylinders rapidly stabilize internal structural dampers against intense mountain microtremors. Brutal level 11 atmospheric wind currents violently rock the outer geometric metal cladding panels. High-tensile structural connection bolts violently fracture and shear off under extreme mechanical pulling forces. Industrial rescue helicopters battle severe vertical wind shear while performing high-altitude platform extraction maneuvers. Highly specialized emergency safety crews deploy thick mechanized anchoring cables to stabilize shifting walkways. This immense infrastructure crisis demonstrates the highly volatile physical boundaries of futuristic high-altitude architecture. Automated plasma thermal fusion systems seal the secondary interlocking alloy support rings to the tower base. Heavy multi-cable crawler rigs rapidly pull massive horizontal carbon steel struts up the vertical rock face. High-frequency electromagnetic structural induction coils instantly solidify newly deposited foundation polymers for extreme strength. Colossal, automated high-altitude gantry transport modules safely navigate complex, multi-level modular decking systems. Industrial welding technicians utilize synchronized computer-guided pneumatic tools to anchor primary framework nodes securely. The internal vertical structural core integrates advanced superconducting magnetic levitation loops for seamless vehicle lifting. Smart dynamic shuttle transport tracks automatically guide multicolored luxury vehicles into designated matrix bays. Advanced optoelectronic laser coordinate tracking scanners continuously capture microscopic tolerance shifts along the building. A central artificial intelligence cluster continuously evaluates millions of structural safety data points across platforms. High-pressure pneumatic carbon dampening cylinders rapidly counter extreme mountain microseismic vibrations inside core walls. Furious level 11 atmospheric wind gusts create massive aerodynamic drag against the geometric metal skin panels. Massive high-tensile structural framework bolts violently shear off under immense mechanical twisting and load strains. Industrial rescue helicopters battle severe vertical air turbulence during critical high-altitude platform evacuation maneuvers. Highly specialized industrial response personnel deploy thick mechanized anchoring cables to secure the shifting framework. This immense infrastructure crisis demonstrates the highly volatile physical boundaries of building extreme futuristic high-altitude architecture. Automated quantum telemetry nodes map real-time structural stress across the secondary interlocking support rings. Heavy-duty magnetic hoisting cables rapidly stabilize thick horizontal carbon steel struts against the rock. High-frequency electromagnetic fusion systems instantly temper newly reinforced foundation joints for maximum density. Colossal, automated high-altitude gantry platforms carefully deliver prefabricated multi-tiered modular vehicular decking blocks. Industrial assembly technicians utilize synchronized computer-guided pneumatic tools to anchor primary framework nodes securely. The primary vertical mechanical core integrates advanced superconducting linear induction loops for seamless lifting. Smart dynamic shuttle transport sleds automatically guide multicolored luxury vehicles into designated matrix slots. Advanced optoelectronic laser coordinate tracking devices continuously stream microscopic dimensional variance data to mainframes. A central artificial intelligence computer network continually evaluates millions of structural safety data points. High-pressure pneumatic nitrogen gas dampers rapidly minimize extreme mountain microseismic vibrations inside concrete walls. Furious level 11 atmospheric storm winds create massive aerodynamic resistance along the geometric metal skin. Massive high-tensile structural connection bolts violently fracture and shear off under extreme mechanical torque. Industrial rescue helicopters battle severe vertical air turbulence during critical high-altitude platform extraction maneuvers. Highly specialized industrial response personnel deploy thick, mechanized anchoring cables to stabilize the shifting framework. This immense infrastructure crisis demonstrates the highly volatile physical boundaries of building extreme futuristic architecture. Heavy-duty electromagnetic scanning grids continuously map the internal molecular stress across structural titanium joints. Massive automated horizontal bracing arms rapidly clamp large carbon steel columns onto cliffside supports. High-frequency induction heating networks instantly temper newly deposited structural polymers for maximum core density. Colossal, motorized, multi-cable gantry cranes smoothly hoist complex, multi-tiered, prefabricated, modular vehicular decking systems. Industrial technicians utilize synchronized computer-guided pneumatic wrenches to anchor critical structural support nodes securely. The internal vertical structural spine integrates advanced superconducting linear induction loops for seamless car lifting. Smart dynamic shuttle transport sleds automatically guide multicolored luxury vehicles into designated matrix slots. Advanced optoelectronic laser coordinate tracking devices continuously stream microscopic dimensional variance data to mainframes. A central artificial intelligence computer network continually evaluates millions of structural safety data points across platforms. High-pressure pneumatic nitrogen gas dampers rapidly minimize extreme mountain microseismic vibrations inside concrete walls. Furious level 11 atmospheric storm winds create massive aerodynamic resistance along the geometric metal skin. Massive high-tensile structural connection bolts violently fracture and shear off under extreme mechanical torque. Industrial rescue helicopters battle severe vertical air turbulence during critical high-altitude platform extraction maneuvers. Highly specialized industrial response personnel deploy thick mechanized anchoring cables to stabilize the shifting framework. This immense infrastructure crisis demonstrates the highly volatile physical boundaries of building extreme futuristic architecture. Heavy-duty electromagnetic locks smoothly engage to secure the massive newly completed vertical terminal quadrants. Automated central diagnostic mainframes run final systematic stress verification protocols across the entire alloy spine. High-intensity optical tracking networks continuously project green calibration lasers along the operational docking decks. Sleek, streamlined futuristic bullet trains, painted in brilliant royal blue, pull smoothly into the terminal. Hundreds of multicolored modern smart vehicles automatically glide into their designated high-tech honeycomb slots. Bright yellow heavy maintenance trucks align in flawless order across the lower transit staging pad. Dozens of industrial technical operators in matching bright safety orange jackets proudly monitor the flow. Vivid, crisp digital billboard arrays display real-time planetary structural load metrics flawlessly. This massive multi-billion-dollar futuristic architectural achievement redefines global engineering capabilities and structural boundaries. This documentary is for education only, based on real sources. Theories are not facts.